Hello Stormwater designers, and welcome back to Clear Creek Solutions hydrology education videos. In this one, we're going to be going over custom dimensionless unit hydrograph project. This is example 3. We have other examples of TR-55 projects we've been running in our playlist that you can find 100% free, as well as a ultimate hydrology guide which describes the various different kinds of hydrology used in the industry, and you can get that guide 100% free. Anyways, this example demonstrates the use of custom dimensionless unit hydrograph in DUH instead of a standard one preloaded in the program. So we're going to run through this project. You can read this description if you want. It says Owen Davies owns a 12.5 acre site in Talbot County on Maryland's eastern shore. Forest covers 1.5 acres of the property, and the remaining 11 acres are presently in Silver Queen sweet corn production, planted in straight rows. He uses conventional tillage with no special conservation practices, and the vegetative cover is typically in good condition. So the soils on the cropland portion of the property are hydrologic soil group C, and D soil groups underlie the wooded part. His plot is almost rectangular with the cropland located on the higher ground. So it describes some more project components here. Owen has considered leaving crop residue on his field to reduce erosion and pollutant discharge into the stream. His daughter, Branwyn, wants to show him what a difference crop residue can make. So we're going to go through the solution here. The analysis has 3 parts. We'll cover a couple parts here in this video. First, enter the Delmarva DUH into the data file. Second, determine the peak discharge and runoff volume for the present field tillage condition. And third, determine the peak discharge and runoff volume for the future condition. So step 1, enter a custom dimensionless unit hydrograph. So I'm going to put BMD, Dad's Farm. I'm going to enter in all these components here. Cornfield near Bug Creek. It's in Talbot, Maryland, according to this project here. So let me go to that. And then dimensionless unit hydrograph standard. Okay, so then we're going to do our storm data source here. She enters user ID. Okay, so the dimensionless unit hydrograph, the storm data source, and the rainfall distribution identifier have default values. The default DUH is the standard NRCS one with a peak factor of 484. That's standard. Click on the global data in the Windows TR-55 main menu, and then go to storm data in the pull down. Global data, there we go, storm data. To bring up the storm data here, so we have Franklin County, Missouri NRCS for this one selected here. So this is the pull down list. It says clicking on the NRCS storm data will fill in the data for Talbot County. So I'm going to click that. There we go. Data's filled in. And then I'm going to select type 2 as our distribution, because that's what it has here in the example. By clicking accept, then we can select the storm data source. I'm going to click accept there, which reflects on the TR-55 main menu here. So we have Talbot. This says NOAA. I'm assuming this is sort of the same thing here. Then we go to Talbot County Agriculture Service Center. Has a table with the values for the Delmarva DUH. She can click on the global data in the Windows TR-55 main menu bar, and then on dimensionless unit hydrograph. So global data, dimensionless unit hydrograph, we can select Delmarva. That fills in the values for that right there, and also allows entry of custom DUH. Rowan enters the Delmarva for the DUH in the local hydrograph box. She then enters the points that define the DUH in the dimensionless hydrograph grid. The point should begin and end at 0.0 and should be no greater than 1. The program will calculate and show the number of points automatically. So we're able to fill that in TR-55. Does an autofill there. She can then click the plot button. So there's the plot. You can see our graph looks the same there. For the dimensionless unit hydrograph, close and done for that portion, for that step 4 there. After returning the TR-55 main window, she must select the Delmarva dimensionless, so we will select Delmarva. Hydrograph from the choices displayed by the DUH pull down for the program to actually use the Delmarva hydrograph in its calculations. After highlighting Delmarva in the pull down choice list, she double clicks on it to enter it as her choice for use. And then if she wants to use this DUH in another job, all she needs to do is click on the name of the hydrograph list. Okay, so we can access that later if we want to. For part 2, determine peak discharge and runoff volume for the present field tillage conditions. So now we enter the sub-area name, corn 1. Description is field by Bug Creek with outlet selected and 0 acres so far. Now we can double click on the acreage area, and that'll bring up our land use details. we're going to go ahead and match this. We had row crops. Let's go to cultivated agriculture. Row crop, it looks like there's 11 acres of type C soil by that 85, so I'm going to put 11 in there. So all in total, or maybe there's a 1.5 acres added somewhere else. Let's see if I can find that there. 1.5 acre of woods, good. So let me go to other agriculture. Let's see. Let's see if I can find woods here. Juniper, oak, herbaceous, woods, good. I'm going to assume that's probably C. No, D soil, so 1.5 acres of that. So that completes our land use area entry there. And we can see we have the same project set up, weighted curve number of 84. So we have everything set up appropriately here. And then we go to the time of concentration details. We can enter in all these different values here. So sheet, 100 feet in length, 858, and 131, 0.1 slope, 0.1 slope, and then 0.095. Cultivated, less than or equal to 20% residue, unpaved, unpaved once again. And now we have our time of concentration hours. I'm going to click accept. Then the sub area time of concentration now appears in the sub area entry and summary portion of TR-55. And then we can click the run. We want to run for every storm event. Click run there, processing, and we can find the hydrograph, peak, and timetable. Then we're going to move on to step 6 and finish this project in the next video. So go ahead, like and subscribe so you can see the end of this project here. If you have a question, leave it in a comment down below. And anyways, we'll see you guys next time.